Let's take a look at wiring up a motor based on the nameplate. Okay, so your motors are your three-phase motors are going to come in typically 6-wire, 9-wire, or 12-wire motors. This is a 9-wire motor here, showing 9 different leads coming out of it, which means the motor was going to be internally wired by the manufacturer, either in a delta or a Y configuration. All you're going to see is the 9 leads here, and then you're going to wire it up depending if you're running it on low voltage or high voltage. So looking at this nameplate, I can see that this is a 3-phase motor. It doesn't say it on here, but it says it's 230 volts, 460 volts. So the 460 volts is telling me that this is going to be a 3-phase motor, plus the fact that it's got 9 wires on it. Okay. The other things you can see, it's a 143T frame, which is a pretty big frame considering it's only a 1 horsepower motor. It's giving us our service factor amps here, which means that we can take our full load amps and multiply them by our service factor to tell us that we can overduty this a little bit right here. I'm assuming this is probably a continuous motor. Yeah, just continuous motor. Okay, so if we're going to go ahead and wire this up, and we had high voltage available, we would make the following connections. And this is internally wired here, so we're just looking for the terminals. So I'll wire this up, even though you're not necessarily going to see this internal winding to the motor. So according to this, we got T1, T2, and T3. So this indicates that this is my line voltage, line 1, line 2, line 3. Same here. It was low voltage, my line 1, line 2, line 3. So if I were to come here, line 1, line 2, line 3, it's going to go to T1, T2, T3, to 1, 2, and 3. So I would be taking this 1, and I could go 2, and I could go 3 like that. And then I would go with my wires 4 and 7. I take these 2 wires coming out of here, and I would put a wire nut on them, and I electrical tape them. Okay, looks like I'd be doing 5 and 8 right here. I'd be twisting those together, put a wire nut on them, and tape it. And the other 2, 6 and 9, I would come here, and I would tape it. Okay, and that's how this would actually winding look if it was delta, and it seems to make sense. It looks like that it's is indeed wired as a delta when we put these in series like this. If it was internally wired like this, what is it really going to look like? We got line 1, line 2, line 3, going to T1, T2, T3. So you got one line's going here, one line's going here, one line's going there, and once again, all these you would just put a wire nut on these, and you would tape them off. We're now looking at T4 to T7. So these 2 right here, T4 and T7, would get run to each other, connected. 5 and 8 would get run to each other, connected, and these would get wired to each other, and you put a wire nut on them. So these jump rings would seem pretty simple, and it does look like it would end up producing a Y. That's the way it was internally wired. Notice the low voltage actually becomes a little more complicated to wire, but really not that much. You would just, in this case, take 1 and 7 in the line 1, wire nut them, wrap them up. Then you would have all these 3 here wired together, and that's really, taking the points to make it look like a Y. We've kind of explored this on the 6 wire. And so it's important just to know your voltage, be sure that you identify the wires, and just be sure that you insulate them correctly when you tape them and when you connect them so you don't get a short.